What's up, everybody? We have a pretty big video today, so I think we need to introduce it a little differently. And that's because we're interviewing not one, but two Offworld devs, and we're discussing performance and optimizations in Squad. Not only are we going to talk about things that are currently affecting performance right now in Squad, but we're also going to be looking ahead at the transition from Unreal 5.5 to 5.7 and future things coming down the pipeline that will hopefully improve performance for the game, especially when it comes to environments, map making, and so on. While you're here, hit the subscribe button, join the comments down below, or continue the conversation in Discord, which will be linked in the description. We recently launched memberships as a way to support the channel, but you can also do that by using my code SLATE3K30 at the link in the description below for 30% off of Squad. Now, today we're going to be talking to Norby, the director of technology. We talked to Norby last year at the introduction of Unreal 5 coming to Squad with an interview, so we're following up on a lot of that information. We're also going to be speaking to Assi, a senior environment artist, and he's going to discuss some of the things that he's working on in terms of performance and optimizations with some of the tools coming with Unreal 5 and 5.7 and how that's affecting map making and some of the things that they have to do to improve performance from the environment or world building perspective. And since this is a pretty sizable video, I've gone ahead and chaptered it down below for specific topics you may be interested in, but we're going to dive right in. I hope you enjoy. I wanted to discuss some of the basics of Unreal 5 coming to Squad. In the last 7-8 months now, since September, like Norby, you and I had a conversation, an interview about a year ago almost to the date. Can you kind of discuss your interpretation on where performance sits within Squad?
UE5, we decided to push it out when we reached our goal of it running better than the UE4 version of the game on most systems. And so that was already on launch day, and since then there have been some further improvements made. And that's just looking at frame rate. The other focus that we had at that time was retiring legacy systems that were causing a lot of hitches. So for example, having a better system to do our large worlds than what we had before, where you were repositioning the game world in relation to your character to deal with position issues. And so each of those reposition events was causing a major hitch. Retiring those kind of systems and getting rid of a bunch of hitches. Those were the two goals going into it. Another area where we have regressed compared to UE4 is memory usage across the board, and that's for every system. Now, it doesn't necessarily reflect in your average frame rate, right? Your average frame rate can be higher on UE5 than on UE4, but we're using more memory, and then we can run into certain issues with that. We had to lay out a plan of how we address that, but we do want to do better on the memory side, and that has been the major focus really the last 6 months, I want to say, especially for the art team, because when we look at what uses memory in a game, most of that is art, and a lot of challenges were around that. Like, we increased our fidelity, of course, going to UE5. Part of that was the lighting, but also the art assets are getting higher fidelity, but at the same time we're trying to reduce the memory footprint. One thing is for sure, the memory challenge is present for everyone now. For us, the decision to work on this was before these memory prices got insane in the last couple of months, and we need to make sure that we optimize, really focus on that area and reduce our memory footprint as much as possible.
For either of you, is there any challenges outside of some of the memory and the legacy assets that you guys feel have like cropped up that you guys have had to tackle differently since the Unreal 5 transition?
I don't know about differently, but UE5 it buys some of the higher fidelity it has due to using memory for certain things. So there's a higher memory footprint just attached to the base of it, and that's something we have to offset in some kind of way. The other new approaches are pretty much coming out of the engine, enabling us to do new approaches. We are a smaller team, and so we don't have all the people to build all the tools necessarily that would be needed to otherwise optimize the game. So we're looking at what kind of tools does the engine give us, and so we're upgrading the engine as we get opportunities to optimize. And so in 10.4, we're going to Unreal Engine 5.7. And the driver for that is really memory optimization opportunities we get out of that engine version.
I think on our side, environment art-wise, we kind of have some challenges in terms of like some of the file sizes, especially for a lot of the foliage that we had to like manually convert to be compatible with Nanite so it runs better. A lot of that stuff ended up kind of going up in try counts, and that naturally just means larger file sizes. And so when you submit and work on a map, the maps were originally kind of like the biggest file that you had to touch, and it still is. But you know, imagine you're going in, you're working on a map, you're having to submit it. You can be waiting like 5-10 minutes sometimes, especially if you're like pulling downloads, and obviously that affects like the whole team as well. So there's ways kind of we're looking at working around that. And then I would say also just the sheer fact that like yeah, in the past we were kind of limited to only having one person working on the map, like on the landscape itself. And so we've kind of figured out workarounds, and now we're finally getting some tools as well to kind of help with that in terms of workflow wise. So
gotcha. And I think this goes into kind of a conversation around tech debt, right? Can you expand upon that some? Having to update some of these assets and that transition that's happening from what we've had in the game for years and having to get it up to speed?
yeah, absolutely. So we have quite a bit of tech debt, but like specifically art debt, I'll call it, for the art side of things. And we're working our way through that, right? So it's been a kind of long journey. Initially for the engine upgrade, when we were kind of first looking at it, it was a case of like, okay, how do we make 25 maps and like 10 years of content kind of work on UE5 and be compatible with it? And now it's more so, how do we improve it? You know, what the findings were and investigations that we've kind of taken on. So I would say, for example, there's a lot of legacy content still out there that has a lot of the old methods and techniques we used to use attached to it. So for example, for lighting side, we had to do some manual mesh distance field replacement meshes. And this is like a smaller, lower detail additional mesh that you kind of pair with the original asset, and to get cleaner lighting results. And, you know, the black splotches, that kind of artifacting we used to have back in the day on a lot of the foliage, that was a fix for that. A lot of that is still present on a lot of those assets in terms of those replacement meshes. But they do take up additional memory, right? So that's something we kind of need to go through and now just unhook, remove, clean up. And the same can be said for like proxy LODs. So that's kind of like when we had like these bigger merged meshes, we would kind of have a merged LOD that kind of simplifies the materials into one texture. And again, it's just extra texture resources that we use, even though you don't see it anymore, because we converted stuff to use nanite, right? And nanite doesn't use those assets, but it still loads because it's attached to the mesh. And I think normal LOD materials as well, there's a lot of those that we've kind of been cleaning up. Imposter LODs for the old foliage, again, something we don't really use because we're using nanite now, but it's still loading into memory. And yeah, just other than that, it's a lot of kind of legacy stuff and techniques we kind of need to investigate again, look at and be like, do we even need this? Is this still loading into memory? And in a lot of cases, like funnily enough, it is still loading into memory. So there's easy wins we can do there across hundreds, if not thousands of assets, but it does take a while to kind of get through. So
just out of curiosity, when you guys have like an engine upgrade like this, how much does that affect like development in the SDK? Like Norby, if you said, okay, tomorrow we're going to be on Unreal 5.7, like what does that do for the team?
We have a lot of tooling nowadays that automates that upgrade process. And part of the transition from UE4 to UE5 was also retiring a lot of things that were not aligned with the engine. We have learned over the last 10 years that a way you can make engine upgrades smoother. And so we did a lot of changes that where friction points were previously in the engine upgrade process, they're not there anymore now. So when a new engine version comes out, we will usually upgrade very quickly just to have a look at it. And so it doesn't mean that we switch development over to it, but you know, Live Squad is on 5.5. When 5.6 came out, we upgraded internally to 5.6, and we look at it. Okay, what does this give us? Does it give us any critical tooling that we need to achieve a performance goal here or not? And it did, but so did 5.7. So we kind of, with every release, we upgrade. We even have access to like more direct development streams from Epic's side. So sometimes we pull even things in that are not in a release yet. So the major release is more like a guideline, a whole package, and then we cherry pick things that are more live in development whenever it helps us achieve those goals. And the biggest area really that has brought technical advancements, it's really driven by Epic's collaboration with CDPR for The Witcher 4. Their goals there align very much with Squad when you look at it from a rendering perspective, right? They want to have large, high-fidelity worlds. That's not something that Epic had as much as a priority previously. They weren't as much trying to solve these problems as they are trying to solve them right now. So there's a lot of good things coming into the engine that help us overcome some challenges. One of those limitations was level streaming, and it brings us back to the whole hitching problem. In Squad right now, you load the entire world. When you're on the map, it's all loaded into memory. And we're doing that because the engine system to dynamically load stuff as you need it, as you move around, you load like higher quality versions of the world that are closer to you and maybe lower quality versions far away. And you're not loading things that are behind you because you don't see them. But then when you turn around, you quickly have to load those. So all these kind of things, they're not happening in Squad because the engine wasn't set up to do this without hitching at the scale that Squad needs. We have too big of maps, we have too much stuff on those maps, and whenever we tried it, there were level streaming systems in the engine from day one. Like, we've experimented with this for over a decade, but we always ran into the issue that at some point it would start hitching. It wasn't a smooth experience. And really only now in 5.6, 5.7, experimentally, there are solutions now to overcome these challenges, and it attacks some of the foundational limitations in the architecture of the engine. In our internal tests, they've been quite successful now in actually using level streaming. So another area is foliage technology, and something that Roger can speak to.
Yeah, so on the foliage side, some people may have seen the tech demo stuff that they showed from the new Witcher game that they're working on, in terms of like the foliage stuff where it's like becoming voxelized and they assemble it out of like modular pieces rather than every tree being an individual asset. And so that kind of stuff helps you save a lot of memory, because instead of having like, say, 12 individual trees, which all cost their own memory footprint, you can now assemble all of those trees out of like 5 smaller components, which are much lighter and, you know, infinitely more variants than you want. And so that's the kind of tech we're looking at leveraging. So we've managed to do successful tests and get good data from the voxelization side of things, which helps reduce overdraw on the assets at a distance. And it also helps with, like, if you noticed, you know, ever since the UE5 upgrade, we've had this issue with trees in the distance where they kind of start to peter out a little bit, right? It's like getting all divoted and there's gaps in it, and it just doesn't look like a full silhouette. And so this directly addresses that visual issue as well, on top of giving us a much more improved performance, like runtime GPU performance. And then as far as the assembly side, that is still pretty experimental and beta stage from the engine side of things. So that's probably still a while out. But we have done initial tests. Some of the other team members have started tinkering with it, and like, it definitely does what it says on the tin. It's currently not production ready and to be kind of shipped. But yeah, the concept is basically, you know, make those trees out of smaller, like, individual kind of branch assets, right? That you can just duplicate instead of having to make unique meshes for every single tree.
Got you. And that is the voxelization, foliage voxelization?
Two separate things, right? The voxelization, it works quite well already in our testing on, so like, this is something that has been in production use for some time now, right? We're switching that foliage over. So this is something where we're feeling good about it based on the results. The assemblies are the memory optimization side of it, and they are not quite there yet. That's a lot more involved. There's more tooling there, but it also kind of charts a path towards what we can do there. I guess the biggest thing for me maybe on that side is, you might have noticed that foliage in Squad isn't really moving much anymore. The wind, like, maybe just really up close, but not further out. And that's obviously an optimization. There's a whole design debate around that as well. Like, do you actually get a better image if you get a lot of movement, or is it maybe too noisy then, and like makes it difficult to spot enemies? So there's that whole side, but there's also just technically there are a lot of limitations around doing that right now. There's a lot of cost attached to it, and that technical limitation is something that this assembly system addresses.
Think of it like, you know, you've seen like modular buildings or like walls in the past. It's essentially the same concept, but for foliage. So if you think of like a pine tree and it has all of its individual branches and leaves, if you want 12 of those trees, they're going to be all 12 unique trees. And now say they all cost like 10 megabytes each in memory, just a random figure. That's going to be 120 megabytes, right? Now, think if you were able to split that tree into like 5 smaller elements. So like, you know, one branch, second branch kind of thing, the trunk, and then you're able to reuse those elements to build all the kinds of varieties that you want. You're only ever going to be paying the memory cost for those like initial 5 modular pieces instead of all the individual ones. So you could have, you know, 20, 30 variants and still be paying the same cost memory wise. Whereas traditionally with the normal methods, you'd go from that 120 megabytes to now paying 300, 400 megabytes. So
the workflow, how an environment artist or a foliage artist is actually creating foliage right now, is very similar to that tooling that's coming into the engine now. So they will not create every tree from scratch, right? They will already make smaller assemblies like branches, and then they assemble them on a bunch of different meshes. And so we're bloating that memory footprint basically at the import side, and now it's moving that creation process into runtime, which is far more memory efficient.
Yeah, that is the great thing. Since we kind of did the research ahead of time, we have a workflow on the artist side to produce the meshes in that way so that we're ready when that tooling becomes production ready, essentially. We won't have to go back and like remake everything from scratch again, kind of thing.
So we've talked a lot about memory and how you guys are working to optimize that. How does that affect players in rounds, the day-to-day?
There are safeguards built into the software, your GPU driver, and your operating system that will prevent you from hard crashing, but it has negative implications that could be frame rate. Quite frequently, it's a hitch that you experience. But when let's say you're running out of VRAM, it will, the GPU driver will start putting things into system memory instead. It could be we have a big hitch because we wait 20, 30, 40 milliseconds to get something out of system memory. It can also be a situation where we're trying to do too many allocations at the same time and overwhelm the GPU driver that way. One of those examples is the pip scopes. The pip scopes are a huge challenge for GPU memory because we are transitioning so many things at the same time there. And so we've done a lot of engineering around minimizing that impact. So when the way the pip scope works is when you equip a pip scope kit, a lot of the work happens in that moment when you switch a kit. And you might notice that when you switch to a pip kit, there is a small hitch, and that's intentional because the switching kits is not something that you usually do while you shoot at someone or another critical moment. But when you switch away from a pip kit or you switch between non-pip kits, you don't get that hitch. So that's actually the pip creation that happens there. And the pip is active, but it's like minimized and not updating to not give you a runtime cost in that moment. But then when you do that ADS transition and the pip needs to be visible, that's when we need all that memory all of a sudden that you need for that separate scene, for that render target. And then we downscale the outside scene. Well, those are a lot of transitions that can end up overwhelming the GPU driver. And that's one of the reasons that the experiences that people have with pip really depend on a lot of factors. It depends on your system, on which manufacturer your hardware is from, which generation it's from, what your GPU driver is, and how much memory you have, of course. These are all factors in how you're going to experience pip. The unfortunate reality is that the most common system setup, so an NVIDIA GPU using DLSS, is kind of the worst case for pip because DLSS limits how much you can downscale the outside scene. The other upscalers do not, right? They don't put hard limits on us. So let's say you're on a 4K screen, the outside scene gets downscaled to 1080p if you were using FSR or TSR or something like that. You don't notice because it's blurred. But all the render resources, your runtime cost goes towards that pip image. On DLSS, we can't do that. It hard caps us on your selected upscaling level. Let's say it's quality. We can't actually downscale that outside scene. So the frame rate loss on DLSS is more significant than with other techniques. And then NVIDIA's driver also has some issues around that large memory transition we do there. Let's say in online communities, you get these conversations and someone says, oh, I got this horrible experience. Someone else said, well, I don't get it at all. It doesn't mean that someone is wrong. It means every experience there is legitimate. It just depends on so many factors. And even if someone has exactly the same hardware config, there can still be differences because maybe their system RAM speed is a little bit faster, and that just allows it to shift some resources into system RAM and out of it quite fast enough right at the edge where then it doesn't cause a hitch. So those can all be factors in there. But what we can do on our end, because obviously we cannot test on every single system out there. And our data shows there's a big variance even with the same hardware in terms of what frame rates people get. What we can do is just do as much as we can to alleviate memory pressure overall, and that then decreases chances of it happening. If you are experiencing issues like hitches in certain situations, the best thing you can do right now is lowering your settings. One thing we're not doing well is being transparent about how much memory the game uses at what point. The reason we don't do that is because we don't know, because it depends on so many factors, right? It can be like the map and the faction you're playing are also having an impact on the memory footprint. There's no way for us to tell exactly how much memory is going to be needed on your system at what setting. But we should probably have more hints around what are impactful settings to decrease memory usage. So lowering texture settings, shadows require a lot of VRAM. They are also a good one to lower. So that can help alleviate some of those issues.
Where do you think right now, more generally, that you're meeting expectations for performance? Or where are you sort of landing? That was a big conversation we had last year in this same interview, was trying to make sure you can meet expectations for a lower end hardware.
We test on a variety of systems, and that's both systems that we have just computers in the office that you can go to and test on, and QA will test on them regularly. And then we have another set of systems that automatically we run tests on every night. We run a build every night, or multiple, depending. Sometimes development is sort of split up because it's a little bit risky. And then we run multiple development streams in parallel, and tests are getting run on all those streams. And that's basically an orchestration machine that spins up the tests on a variety of different hardware. And those tests typically, they're all performance focused. It's like going on every single map, looking at a bunch of different places on that map, and reporting back on that. And then we also run replays. So we have community has provided us with a bunch of replays of 100-player matches. And then we can replay those or sections of those where it's like right in the middle of the battle, and we just follow a single player along for a couple of minutes. We run those replays as well. And then we have a dashboard that prints us all those data points out really easily. And that's maybe the best way we can easily track how our changes impact performance. And the kind of hardware we're looking at, it's what you see on Steam, right? So the low end is a 1060. That doesn't mean we don't look below that, right? We're also testing every night on below min spec systems. On those systems, probably the experience isn't super consistent. That's what we're saying, below min spec. But the game still runs on low end systems. We're actively testing on there. We're actively optimizing on even those below a 1060. And then the highest end of what we test on is actually our target machine at 3060. We don't actively test on anything newer than that. It's not true that every game dev has a 5090, and that means they don't get to experience the issues that some players out there might experience. We actually have just regular hardware. We don't have any 5090s even in the studio. We don't have any 4090s in the studio. We don't even have a 4080, technically, I don't think. And so these two GPUs here, they're 10 years apart, and they have the same amount of VRAM at similar price points, right? This was $350 10 years ago. For the same buying power, probably you would get a 5060 Ti now. You're definitely not getting a 5070 at that price. So we haven't gained any VRAM to work with in 10 years. And if you look at another 10 years before that, GPUs had maybe half a gig of VRAM. So we had a decade where we had a 16x memory improvement for game developer to use. And if we translated that to today, we should have GPUs with 128 gigs of VRAM, but we don't. And that scenario, obviously, we could put the entire game into VRAM, right? There would never be a question about how we manage these resources. But the reality is we have massively increased visual fidelity. The compute power between these chips is massively different, right? It's just the memory that is stagnated, but this one is probably 10 times faster at computing things. So we need to make use of that compute, but we need to constantly change what's in the memory because we have so little memory to work with.
Let's talk a little bit about the transition from 5.5 to 5.7. We've already talked a little bit about it. Norby, what are the overarching goals? And then are there, when you do this transition, are there tangible goals in the form of like metrics attached to something like this that you can find later once it's in kind of delivered?
Yeah, so our goal for delivering 5.7 right now initially is that you don't notice. That's kind of the best case scenario because there isn't really anything in the engine that gives you improvements out of the box. And I think Epic has been pretty transparent about it this time as well. And one of the main goals of Squad is that we have visually comparable experience across all settings. So whether you play on a 10-year-old system or a modern system, you don't get a visual advantage in either case. And it's not like lowering your settings allows you to spot enemies more easily or the opposite. We are doing this transition now because of how the development pipeline works and what it unlocks us to work on at the same time. So we went on to 5.7 internally pretty much when it released. We started experimenting with the technologies that allow us to save memory, specifically the level streaming, the Foliage technology. And as we are working on those, the way development pipeline works is that we have sort of our current release. That's something where we always might need to push a hotfix because someone might discover an exploit one day or something like that. So that's kind of its own chamber. And then after that is sort of the main development stream where everything for the next release is going into. And then after that, we have individual development streams where stuff that's more experimental there. So we need to move things down that chain step by step so that the next thing, all these optimizations can come together and go through all the QA passes necessary and then go out. So the initial release of 5.7 isn't bringing all these optimizations because they are being developed then in that next content stream. They're sort of off in all their own little streams right now. And so it's bringing that together and then getting it ready to release in the one that comes after 10.4. This is definitely the biggest performance optimized effort and release in the entire history of Squad. I've been here from the start. I've never seen such a focused effort because there was never the ability for all the disciplines to come together like that. Like the majority of the art team is probably right now only optimizing, right? That kind of really focused effort on optimization, a lot of these things just need to be merged together and then brought out. And it just enables us to do the next big release after, which is our big optimization patch.
Optimization patch?
Yeah, that's right. So that is why we are doing these upgrades, right? It's to enable us to get those memory savings, runtime savings as well on that Foliage side, what Roger has explained.
That's not 10.4.
No.
Okay.
10.4 is just the engine. The engine is just the prerequisite. The engine doesn't fix any performance issues on its own. You know, the way that Epic likes to put it is when you have performance issues in Unreal, it's your own fault. And they're not wrong with that, right? It's the engine doesn't necessarily tell you how to do things very well, and it doesn't tell you which kind of games are going to work well on Unreal and which kind of games aren't. But we all like Squad, and we want the game to be the way it is. It doesn't mean we want to form it around the limitations of the engine. So we constantly push those limitations. And then when we push them, that's where we are creating the problems. It's not Epic creating those problems. It's we're using the engine, probably not in the way Epic intended to.
That's something interesting because I've heard you talk about Witcher. I think we talked about another game potentially last year, is that the devs are finding things that they almost need implemented into the engine that Epic has to then address. Like it's almost in reverse because you guys are like, well, we have to build this world. I mean, I know that there was tech we discussed last year that it's you're looking at it, and whether it's vehicle physics or something, right, you may have to go a step further than what Epic offers in Unreal Engine to accommodate the needs of the game. So I'm assuming that conversation, like in my eyes, it's like, I guess, untrained. It would be more so Epic gives you these tools and you build within the constraint, but it sounds like it is much more flowing both ways than maybe the average person might understand.
Epic does stuff for the CDPRs of the world, but not for our requirements. So Squad wasn't really driving them to do these changes they are doing now to the engine that enable us to support Squad's use case better. But they're doing it for The Witcher 4. But that doesn't mean we're benefiting from it. We're getting this stuff out before The Witcher 4 comes out. So we have to pick our battles because we're comparably a pretty small studio. So there are areas where we do write our own systems within the engine, where no one else has these use cases, like we're putting tanks into the game and track vehicles, that sort of stuff. And we just have to bite the bullet and write our own code there. So when it came to level streaming, we have explored concepts of how we can write performant level streaming systems. But because you're sort of touching the entirety of the engine when you create a system like that, we were much better off waiting. And it's not like we are passive in this, right? We are in communication with Epic. They come visit the studio and we have exchanges there. Like they are well aware of our needs. But we do understand what's coming down the pipe in a year or two maybe. And so we can plan towards, okay, we're going to make use of that. We would have probably never gone to UE5 if we weren't sure that we reached this point where all the things we need for Squad to succeed on that engine are actually there.
I think we've kind of touched on it, but I want to make sure I understand. What is, first, level streaming? What is the player going to notice from level streaming?
Level streaming is another one of those things where the ideal outcome is that you don't notice it's there. But what it does behind the scenes is constantly unload things that you don't need right now and only load things in that you need. So as you traverse through the world, it will decide what is going to be needed, what you're looking at, and loads the higher fidelity versions in up close to you. And then further out, we get distant representations that are simplified and cheaper. And behind you gets unloaded, and massively reducing the memory footprint of the loaded world. Level streaming, the way Epic designed it, is more focused around actor count optimizations. This is more than an architectural concept in Unreal, where sort of everything is an actor, like a building out there. Any object in the game world is going to be an actor. But it's object-oriented approach to game creation. So where you have the data of the object and its logic, its functionality, all in one big structure. And it's very inefficient from a performance perspective because of the way you access memory. It's the stuff you need isn't sequential typically. So you have to do a lot of memory jumping, which is very slow. We write software in a way that allows us to be as optimal a memory access as possible. And the optimal outcome is always that the next thing you need is in the next memory cell over. So a better way to approach things is in an entity component system architecture. And Unreal has some of that, and we've written some of our own where we really need it for performance. But traditional Unreal in UE4 and UE5 is based on these actors. And Epic had really the goal to reduce them as much as possible because there's a performance cost attached to just having a lot of actors, and you'll have 10,000s in many cases. Like how many actors do you have in a map, right? It's a crazy number.
And 50K for Foliage.
How many?
Yeah.
50,000 for Foliage before we did any manual instancing and that kind of stuff. So
okay.
Yeah, and so for many things, the engine just has to iterate over those 50,000 actors, and it's a very slow thing to do every time. So that was Epic's driver for it. But we went beyond saying we want just this actor count optimization. That massively drops when you have stuff unloaded, but we wanted to also unload memory. And a large part of our memory footprint is the physics collision world. Right, you have all collisions loaded at all times, and we generally have to, because combat in Squad can be extremely low ranges. Right, you could have tanks shooting at each other from 2 kilometers away. It happens. So we cannot just hard cap sort of the collision world somewhere, because the gameplay needs to happen there. So with the way we're handling it, we have our custom solutions built on top of Epic streaming system. That's sort of where we pick our battle again, because the wins are so big, where we are streaming in more simplified collisions, just the things you need. And when you're streaming so much, you need to have a really performant streaming system, and that's what the engine didn't have previously. That's only what it's getting now, where they're getting rid of some of this overhead that's in the old actor architecture. So you should notice an improvement in frame times, but the main thing is a significant decrease in memory load. And if you're on a system where you might be ending page filing when you run out of system memory, right, you're not crashing the game, you're just ending using part of your SSD for getting data out of that. That's also one of those points where you could get a lot of hitches.
Assi, I'm gonna send this one to you for foliage voxelation. We've talked about some foliage improvements, and what does this tech do? What am I gonna see in game, if anything specific, from this tech that's coming in? I guess 5.7, correct?
So it's in the engine, but it's not shipping yet. So we were in kind of like the initial stages of testing it out and seeing if the actual numbers add up and if it is an improvement. And so we definitely got some positive numbers. The improvement, voxelization wise, like what you're gonna see visually is like silhouettes for forests are back at a distance, right? That's like a huge improvement visually there. Depending on how we end up doing the final configuration, because you can change the voxel sizes, and imagine like it's Minecraft, right? Like you have blocks. If you want more voxels, it's going to get more granular, so smaller blocks meaning more detail. So depending on how we kind of configure that final number, you can get, better visual results for slight cost on the GPU. But from the ones we originally tested with, the results were already pretty good visually. You didn't really notice the voxelization that much, and it kind of kicks in like 20, 50 meters, so it's kind of not that noticeable. And then obviously it drops the amount of overdraw, so obviously better GPU performance there outright. And then on the engine side, it's us kind of tweaking the CVAS to get the visual result and performance trade-off that we're kind of after. We did a bunch of, Norby mentioned, we have like automation tests that we run. I can just submit some changes on a separate stream that gets run in a build, runs through the automation pipeline, and then we have like immediately just those kind of like GPU cost comparisons, memory comparisons, and all of that kind of stuff. And so the topic kind of expands into the general Foliage stuff, where the Eastern Europe stuff that we're working on, it is going to be like all of the foliage is basically redone from scratch with better methods suited for nanite, because with the legacy stuff, we had to basically convert it, right? So originally nanite like still doesn't support translucency, and a lot of the foliage was using that. It does support opaque. So opaque is just anything that you look at, right? Like a building, you can't see through it or anything. It's just a solid thing. And then masked. So sometimes we would use masks to kind of cut out leaves or like certain decals or that kind of stuff. So that works with nanite. But obviously masked is significantly more costly on the GPU. So we had to come up with a more kind of conversion process for that to kind of make it more compatible. And so originally we switched to masked, and we found like this is still way too expensive on the GPU for the amount of foliage that Squad has in its maps. And so we did kind of like a shader switch where we basically converted the original foliage, which was using masks, to be just flat geo now. So you still have everything like made out of mesh cards where they kind of intersect like planes. And that just, again, causes a little bit of extra overdraw. But the good thing is we managed to make some savings there, switching it from being masked to just opaque. So it just works like any other object. But with the new foliage, we're kind of making that in that 3D kind of geo way, right? So it's not intersecting planes, mesh cards, whatever, right? It's like actual detailed geometry, and we can kind of configure the leaves to be as detailed as we want or as little as we want to kind of bring down the try counts. And so all of those methods combined will lead to foliage that it uses way less texture memory, because we've been able to kind of assess all of the foliage assets we have in that biome and plan it out, so we reuse textures a lot more. Whereas in the past, the foliage was kind of created in individual sets, so there was a lot of just individual textures for use for a lot of different stuff through like the various species that we have. So texture memory is going to be improved on that side. Mesh memory is going to be improved on that side, because the old legacy converted stuff was pretty heavy. Like some of it was like 1 to 2 million tries. And not only does that result in like a lot of mesh memory being used, it's also just crazy on the file size that we have on the editor side. The compression is great for nanite meshes. Like we've dropped a bit in terms of like file size usage on the game itself once everything's like cooked there. But yeah, like on the editor side, it's been pretty hectic. And so we're cutting that down. And then obviously the voxelization is going to address the performance side and also the visual side that we've kind of had issues with.
Okay, so that, I mean, it sounds like the biggest case study is going to be the Eastern European biome rework then.
Yep,
that's
absolutely.
Where the most work is being put, or most efforts being put into updates.
Yeah, so with a lot of the legacy stuff, we just reach ceilings with what we can do, right? Because it's completely different techniques and methods that we used, and they were put together with different, assets, shaders, all that kind of stuff. You kind of reach a hard ceiling of like, well, if we want any more gains out of this, you might as well just remake it from scratch with better methods suited for nanite and suited for UE5 specifically. So that's kind of like the wall we ran into. So it is, a massive undertaking, because we have a pretty small art team as far as art teams go at studios, especially for a game that has like 10 years worth of content to get through. And so even if we strip that down to like Eastern European maps, right, we have like 24, 25 maps in total, if you count like the training ranges and stuff. And And I think a good percentage of those, maybe like 8 to 10, are like Eastern European maps. And so, they also reuse a lot of the different assets from the different biomes, right? Because in some cases, you have people that will kind of put together a map using some of the Middle East stuff, because it's like some props that just kind of fit in there, right? But yeah, for the biome rework itself, we're kind of focused right now on the rural aspect. So that will be like all the villages, sheds, garages, props to go with that, walls, fences, stuff in the backgrounds. Back garden, sorry. And then also we've taken it a step further by kind of looking at interiors. So I think we've already shown that off in the past, right? Like we started working on adding some interior props. I think that was posted on X like 8 months ago or something. So yeah, it also gives us an opportunity to kind of dip our toes into that sort of stuff that Squad never really had consistently, right? Because there's some massive buildings that have some props inside, and then you have a lot of old stuff that just has nothing inside it. And so we kind of looked at that and we were like, yeah, we want to up the fidelity there. We can do it because we've improved the way we make the assets, right? We've made a lot of room. If you kind of like compare the two biomes in terms of like memory, the village houses, for example, are made out of a modular kit. And while that modular kit is pretty extensive, it's still way cheaper than all of the kind of individual houses that we had put together on like the legacy assets. So yeah, biome wise, that's kind of kicking along. It is a lot of content that the team's working on right now, and I've kind of shifted to that more technical role. So on my side, I get to focus on all of the performance and optimization stuff, like full time essentially. But then the rest of the team, they kind of did a pass on a lot of the old stuff to kind of help. I think maybe like 6-ish months ago. But yeah, now they're kind of like full speed ahead working on the biome stuff.
Okay, and I know as some of the material you guys provided beforehand, there was a discussion about bringing maps to a baseline, and that's an ongoing thing. Can you talk a little bit about that? And I know that there were some maps listed as okay. So first, like, what work has gone into the baseline? What is the baseline? And then what maps should players expect to see soon?
Yeah, absolutely. So the baseline stuff is more. This can be done on like any engine version. This is just sort of like getting the maps to a basic standard, right? So kind of cleaning up a lot of the stuff that I mentioned before, where there's like, useless LODs on a lot of the old meshes. So it's going through cleaning up as much of that stuff as possible on a per map basis. And obviously a lot of these assets are shared in other maps, so there'll be some small improvements in other areas as well. But focusing on it as a per map basis allows us to ensure that like, these maps that we work through, they're at a consistent standard. It's easier to maintain stuff. We know there's not like any easy gains that we kind of left on the table because we didn't kind of see stuff before, and like the new profiler also helps a lot with that. So the baseline stuff is a lot of cleanup and just general asset and map related optimizations. For 10.4, I have a list here. So there'll be Al-Basra, Fallujah, Gorodok, Hayu, Mutaha, Nava, and Yaharivka. And those are sort of like the most popular maps as well. So people should kind of feel a general improvement. And so, yeah, there'll be some slight memory improvements there, like maybe 100, 200 megabytes. So, it's not going to massively move the needle, but that can be the difference between somebody feeling a bit of hitching versus like having a much more smoother experience. And then obviously runtime GPU performance with the way we configure the foliage. A lot of the old stuff, kind of like Norby mentioned, the wind, right?
Yeah.
Way too expensive on the GPU, and even more expensive with that legacy foliage stuff that we've converted to be compatible with Nanite. So yeah, just going through and ensuring that's also at that consistent baseline, and we don't have any like crazy in-configured foliage.
There's a lot of tools obviously with Unreal 5 that has helped in world creation, map creation, and all that. Can you just briefly talk about how much the process has changed and improved from what that would have been a year and a half ago to now?
On Al-Basra, we've shipped with PCG, which was like a flagship thing with the engine. We've used it on Al-Basra initially to kind of dip our toes into it, understand how it works, and just see how it kind of fares in a production environment. And so we use that for like the crop fields, like the wheat fields, rice fields that you see in Al-Basra, then the orchards, like the palm tree orchards with like the mounds on them. And then also in the vista. So like anything outside of the map that you see in the distance, you probably see like a bunch of towns or buildings. That was actually our lead environment artist to put that together with PCG, where, instead of us just hand placing all those buildings out there in the distance, he just made a PCG graph that kind of just like, you just outline an area where you want the town to be, and it just generates like a town that's kind of like in the shape of streets and stuff. In a lot of cases, it's a big time saver, right? Because you just invest that initial time to kind of make a system, like for example, the orchards, right? Like we used to hand paint that stuff like throughout the years, and it was a big contention point in terms of like this takes a long time. Whereas now we have a graph that I put together way back when, where you just outline again with a spline where you want the orchard to be, and you can set your distances, how far the trees are apart on like a grid pattern, and then it also places like a mound mesh to go with it, right? So now everything's kind of looking a bit more authentic. If we need to go in and optimize anything, you just do it in that main graph, and it propagates across to all the instances of the map, whereas like in the past, like good luck, you need to hand paint everything again, essentially, right?
Reduces bugs with like individual placement of specific meshes.
Exactly. Like we have a lot of floating things in some cases, right? When it comes to foliage, there is some tooling provided with the vanilla tools where like you can press a button and it will flatten, or it will drop the mesh down to the landscape. Whereas with PCG, because you're sampling the landscape, it's automatically going to be in the correct place. And so again, saves us a lot of handwork, because in the past you get a bug for that, you got to go in and find it, manually paint it out, fix it. And so now with the Eastern European stuff we're working on, we're going to be using that for like full forests, and that's kind of like the traditional like original way PCG was kind of pitched. You see a lot of our forests in the game across the years, like a lot of that is just quickly painted kind of by hand. Just because it's the sheer scale, right? Like 4 kilometer maps, 2 kilometer maps. And yeah, that can lead to a lot of things like overlap in trees, right? I'm sure there's been plenty of cases noticed by the community by that. And again, PCG allows you to just immediately eliminate that issue from the get-go. Like you never run into it because you're sampling different points. You can set minimum distances between the points. And again, it allows you to make stuff rules-based. So we can, look at forests, do the research from like the science perspective, use the minimum distances and averages to kind of have a forest that feels a lot more believable and authentic. And it allows us to easily maintain that if we need to optimize it further or make any iterations on that.
Yeah, iterating is so much easier. Like I've seen like walls, fences, and then you decide to move a road, and like you can just move the road, and you don't have to rebuild everything because the fence can adjust itself along the new location of the road. Like those are things where that throwing a map together as like a first concept, maybe it's not even that different in time, but then iterating over it to the finished product is many times faster that way.
Is it fair? And that question came from Aidenhoff, who's a design tester, and he was curious about some of the tools and how it plays into the workflow. And I think what I'm gathering is just the amount of effort that's going into the Eastern European Biome rework. It seems to me like it's not just updating the maps, tweaking some settings. It is you are rebuilding. Is that like a fair assessment into getting it not only up to speed but utilizing the tech that is now present in the engine?
Yeah, we're essentially kind of fixing our pipelines and workflows and building it up to be future-proofed, right, with like modern techniques. Because a lot of the stuff on the old maps was just done, just manual labor, right? That's why it kind of takes a long time to put a map together of this scale, especially with like the fact that we had limitations before where you can only really have one person working on the map because everything was in that one map file. So we've done workarounds where we've kind of designed a workflow where we split all the POIs. So imagine all like Neva Upper is its own sub-level, and now an artist can just go in and work on that while somebody else works on another village, right? Like, so like the Eastern Europe stuff, we're working on the assets. So that's like the biome itself as an art team. But then the level designers are working on, additional maps to kind of use those assets, right? And from the legacy standpoint, it will take a bit of time to go through the older maps and replace the old stuff with the new stuff. So there's a couple of steps to it. And I know there's kind of been some misunderstandings in the past in terms of like our communication not being clear enough. Because we would kind of say like, oh yeah, we're working the Eastern European biome, and like to us we know exactly what we're doing, right? But from the outside that can be like, oh cool, they're about to update like 10 maps in the game in one update. Yeah, it's more so like we're making the assets first with the new methods and techniques, and then we need to do the work to use those assets on the old maps, replace them, and obviously use them for new maps too. So
but the focus is definitely on optimization side there of
Yep.
yeah, we don't want to go in and say, okay, well, these old maps, just throw them in the bin and use all this tooling to quickly create new maps, because the old maps matter. Like, people know them really well and they love them. And so the majority of the man hours for sure are going into making sure that we optimize well for that content.
I have some specific things that I'd like to ask, and I'm not sure who to kick some of these to, but I want to get into some of the things that I see in gameplay or that have been brought to my attention in gameplay. The first thing is sometimes when you spawn in, or sometimes when I'm in admin cam, which is obviously more of a less prominent issue because not every player is going to get an admin cam. Sometimes you see textures kind of popping in and out. Typically when I spawn in a hab, there's a few seconds, maybe longer, where the hab may look kind of Play-Doh is, I guess, the best way that I've used to describe it. Can you guys explain what's happening there and fixes that may be coming at some point?
That's kind of what happens when you let programmers address art issues. And the textures exist at different resolutions, or different, they're called MIPs, different MIP levels. And the engine is streaming in the sort of MIP that it knows at this time you need. But in certain situations, like you just spawned in, or VFX suddenly starts playing, the engine had no heads up that you're going to need these higher quality MIPs there right now, these higher quality versions of that texture, and it gets caught off guard, and it needs to suddenly bring those up. You can let the engine run unthrottled on that. You can say, okay, give me all these textures all right now, but that's how you get a hitch. So you're typically overwhelming the GPU driver at that point in terms of just pure allocations. And it's really weird when we profile that in the way it shows, and it's not always really clear, like the same thing that's happening there. But under the hood, really what's happening here is that we're asking too much of the GPU driver to do in terms of memory, getting us all these high resolution versions of these textures ready for rendering. So we cannot really wait for that. And the kind of programmer fix to that has been to just set a hard cap on how many high resolution versions of a texture we allow every single frame to be streamed in. But that then means when you have these situations where a lot of textures has changed, like you just spawned here, or a VFX is playing that is built out of 11 different textures or whatever it is, that the engine might pick sort of the wrong ones to bring the higher resolution versions in first, and it takes a while for it to have the entire scene covered. But on UE5, as we were starting to use more memory, we were starting to see these hitches were getting more severe. These hitches were happening on UE4 as well, and we didn't like them. And part of the effort of going to UE5 was reducing the hitches. And so on UE5, we were looking at it and we're like, well, this is even worse now in many situations because we have put even more pressure on memory. We got to fix this somehow. And so we did the programmer fix, which is the easy way, but not the right way to fix things sometimes. And so we're not happy about the way this looks right now, but it doesn't hitch because of that reason. So we are working on it on the art side to optimize it. And a large effort there is transitioning away from using traditional streaming textures to virtual textures. And virtual textures are more memory efficient. A virtual texture system, you only load that part of the texture that you actually see on screen. It's based on tiles, and so your screen is sort of split into many different tiles, and you load in part of the texture that you need for that tile. There are, of course, other limitations with that system, right? There are ways you can overwhelm that virtual texture system, but it is absolutely a more memory efficient way to go about textures. And so a large effort over these last couple of months has been to switch over to using virtual textures for a lot of things. It has a big memory impact, and yeah, this is another thing that you'll see going out in the next release after 10.4.
Does that include my explosions?
Yeah, so VFX, we have a lot of VFX in the game.
Because I need my explosions, Norby.
The effect that plays doesn't even only depend on the projectile that you fire, but it's also the surface that you're hitting. Mm-hmm. Each one of those has different effects, and sometimes they're like reusing parts of it, but then different ones. Let's say you hit wood, there's a certain impact effect that is generic to multiple materials, but then you get some wood splinters mixed into it. And so we have a lot of different effects variants, and there's a lot of work going through all of them. And some of them have different limitations, but the vast majority of them should be in a good place.
After 10.4.
Yeah, so the optimization release after that. That's right.
Okay.
The engine doesn't fix it for you. What the engine does, though, is that the virtual texture system, it's still quite new in the engine, but that virtual texture system is more mature in 5.7 than it is in 5.5. So we are seeing less bugs with it. Yeah. So like engine level bug fixes is something that's continuous and where we do benefit from the engine, but just going to the new engine version doesn't make this issue go away. It's we have to fix it because it's our issue. We're overloading the texture streaming system, and we have put a hard cap on it to not overload it, but that has visual implications.
Yeah, the virtual texture stuff, especially on the environment art side, there is hundreds of and thousands of textures, and also like the shaders that are used, right? So again, it goes back to the previous thing I mentioned in the past, where like a lot of the legacy assets were kind of created at the time, so they use different shaders and they have their own unique textures. And the virtual texture conversion process is fairly simple. It's just time consuming because you basically need to open up that shader and then convert the samplers, so like the way the shader samples the textures, to be compatible with virtual textures. And then you need to go in and kind of find all the child instances of that shader, and every single texture that they use, you need to then obviously convert that to also use virtual textures. And that is just a tick box. But the problem is, like, if I open up shader A and I fix 10 of its instances, I then address all of those textures. Well, those textures now get used also in a bunch of other shaders throughout the game, because some of that stuff is reshared, which is good. That's what you want. But in this case, it results in incompatibility. So you end up breaking some of the other shaders. So it's kind of like a spider web effect, where like you fix one thing and then you need to fix like 20 more that are broken as a result of it. So there's nothing inherently wrong with that. It is just a very long time-consuming process. But yeah, the gains are pretty substantial in terms of like the memory gains that we can get. And again, it's like building for the future, because all of the new assets that we've been working on, they don't have that same setup where you need to go through hundreds of shaders, because we only kind of have like the 5 or 6-ish base ones. So again, maintenance is a big deal for such a small team. So
since you mentioned like shaders, I think there's a point to make as well about just pure shaders and hitching around that, because it's, I think, a well-known issue in Unreal that you have these hitches around PSO. So not PSO is the correct term for DirectX 12, the pipeline state object. It's it encompasses the shader. The shader is the program that runs on the GPU. The pipeline state object is more than that. It's the shader plus, well, maybe you can imagine it like configuration for the shader, how exactly it's used. And so that's a DirectX 12 concept for performance reasons. So every single pipeline state on the GPU and DX12 is predetermined and fixed. And so when you have many different shaders and then many different configurations, you can end up with many thousands of PSOs. And then you have systems that try to ensure you have them all precompiled so that you don't hitch during gameplay. But it doesn't work quite that well, right? It's not 100%. It's 98% or whatever it is. The way it works is that you pass this to the GPU driver saying, I want these PSOs, and the GPU driver says, okay, well, I'm going to compile all these on the CPU. And that's why when you change your GPU driver, when you update it, it needs to happen again, because now the GPU driver goes through that list again and compiles them again. So you can predetermine that in some games, but in Squad, it's really hard to capture every possible PSO state. In the engine, there's a lot of people at Epic who do a lot of smart things there to try and capture as much of that as possible. And it kind of mostly works in 5.5 and 5.6 and 5.7, but not 100% of the time. So there can be some cases where you do get a hitch that's caused by a missed PSO. So the GPU wants to render something, or the GPU needs to render something, but it doesn't have that pipeline state available. The GPU driver is like, hey, CPU, give me that pipeline state real quick. But then that's just going to be a slow thing, because it has to go to the CPU and compile that. And those kind of exchanges are always what cause slowdowns. So that's where, the less shaders we have, the better, because chances of having many different PSOs is reduced.
Let's talk a little bit about lighting in some of these environments. One question that got brought up, and it was not something I think I really was paying a ton of attention to until I saw some screenshots of it. And this comes from Eye of the Hawks, who's another design tester. And it kind of comes down to dynamic lighting adjustments. Like, for example, if I focus on something, the peripheral starts not only change in brightness, right, but it gets hazy and it gets hard to see. Can you guys discuss like what's going on there? Is that intended, or is that just a byproduct of something else?
Yeah, it's multiple things. So in one case, we do have obviously eye adaptation, auto exposure, whatever term you want to use. And so if you look at something that's like dark in terms of like the value, your eye adaptation is gonna, adjust to that, right, for the whole scene. And we've seen issues with this in the past where like sometimes you bring up your iron sights and suddenly like the lighting looks like it changes in brightness, and that's because iron sights in most cases are a very dark material. So there's ways kind of around that with like masks, but then you have the environment cases where you kind of go up to a wall.
So yeah, the important thing is that it meters on the mask, and it's basically it looks at a center focused area to determine its exposure, similar to how your phone camera will typically do it. And that means objects on the edges don't drive as much into the exposure determination as ones in the center.
Yeah, to continue that essentially is that like it's kind of a little bit more tricky on the environment side of things, because you as a player can just walk up to a wall that's dark and then you try to peek it, and now suddenly you're looking at like a super bright scene, like say a desert, right, Al-Basra or whatever, right? And so you'll notice those kind of shifts in exposure. But there seems to be kind of like another interaction in play where the haze gets adjusted a little bit depending on kind of how high and low you look. And because we do have like fog, like distance fog, it's been pushed back quite a lot now that we have much larger draw distances, but you still need a certain amount for it to actually feel believable. And so there might be an interaction that we kind of need to investigate a little bit further in those cases where it seems to be also adjusting the fog values a little bit, because at the end of the day, fog is kind of like a lighter kind of thing you're looking at in the distance. So as your exposure adjusts, the fog can also get adjusted by that essentially. And there's some tricks that we've used in the past on the effect side, for example, with exposure, where you kind of like divide in the shader. This is like shader code stuff. You divide the emissive by the exposure value, which means you get like a much more accurate result rather than having like, look at this nice scene that's got some fog, the haze is kind of rolling off, and then you have this explosion that just pops out and it doesn't look like it blends in at all with the environment, right? Yeah. So that's like a little trick used there. So there might be something further that we need to investigate on that side. But yeah, I have noticed that as well a little bit. It happens in edge cases, but it's like you mentioned, it's one of those things, once you see it, you can't really unsee it. So.
Yeah, it's the eye adaptation, I think, makes sense in a lot of the scenarios, and it's that extra thing that you're talking about. It's like one more piece that's there that's interfering with clarity more so than exposure.
I think what maybe helps to understand is to look at where any volumetric effects like fog are happening in the render pipeline. Like you have all your mesh stuff, and then you're lighting it. Then after that, you do fog. But at the end, you do all your post-processing effects. And so anything that happens there is on the scene that already contains the fog and can affect it in any kind of way. There's a lot of things we do there in the post-processing pipeline. And so we need to look at that closely and understand what could potentially affect it. It might not be the fog itself causing it directly, because it could be the post-processing also kind of working it out. We have seen like anti-aliasing can have an impact on fog and that kind of thing.
Tagging along with just lighting, just real quick, is some of the baseline work on maps and stuff like that and getting them all up to a standard, is lighting being adjusted in some of these buildings, or does it just get adjusted? Is that something further down the road? For example, if I'm looking at a window and the window just appears, that's still a little too dark. That was something like in playtesting, for example, was a big balancing act. Is any of that still being worked on?
Yeah, so that is something we need to do a pass on. That'll come in the future. The only lighting work I'm really touching for the baseline passes is in terms of like the performance, where some maps will have like interior lights in some areas, like bunkers and stuff, and I'm just kind of making that in a more optimized way where there's like less overlap. You know, sometimes there's less useless light sources that still make it more expensive on the GPU and that kind of stuff. But in terms of like the visual clarity and like looking into buildings from outside and how dark they are, that is very much a design driven thing. So unless the design team feels like, yeah, we want to make an adjustment to that, we don't really touch that kind of stuff. Like we do the configuration of it and ensuring we kind of get what they intend visually to the game to look like. But yeah, it's definitely a design team call whether they kind of want to lighten that stuff up. And I mean, yeah, there's a lot of feedback that I've been seeing over the last kind of like few months in the community surrounding that. So there might be a time to kind of look at that and make adjustments.
Are there any updates coming for water and maybe some of the baseline stuff or future updates? Because I know sometimes, for example, folks will look towards water and they might see some sort of adjustment in their performance versus looking away from water.
Yeah, so the ocean shader stuff, this is kind of like the generic water shader that we have. We try to use that as much as possible, but it might not be useful in some cases, like on river splines and that kind of stuff. But if we're talking about like the large ocean bodies of water, like the stuff on Black Coast or Sanshan, yeah, I haven't had a chance to kind of dive deeper into that. It is a much more complex kind of shader system that the tech art team put together.
Yeah, one thing I know is that it's also getting looked at from a memory perspective. So for example, the way it works right now with the oceans is there's a masking system that it's basically a texture that defines where we have ocean and where we don't, so that it isn't just like one plane of ocean water all under the landscape on land, but it's just limited to the part that should be ocean. Like how do you define where there's water and where there isn't, right? That's really the question there. And so that used to be or is right now a texture, but then that's a texture that really doesn't have any other use, and textures take up a lot of memory, every single texture. So they've been finding a more optimized way to do that. So these kind of things, right there, everyone's looking at, does this really need to be in memory? And then if the answer is no, how do we do it differently?
So to close out, what is something you guys would both like the community to take away from what we've discussed today?
I think the most important thing would be that like we definitely see and hear you guys out there in the comments and the YouTube videos, Reddit, Discord. We are working on a lot of these performance issues, and some of them do take quite a bit of time to get through just because we have like a small team. But ultimately, like, yeah, shouldn't really matter. The point is we are working on it. There's going to be gradual improvements. So the immediate stuff that we kind of listed before, with like the 7 maps coming into 10.4 to kind of push the kind of boundary a little bit in terms of like improving performance there. There's all sorts of big stuff that we're kind of putting in that we're gaining as a 5.7, allowing us to do this stuff that we're working on now. So that'll come in the future. And then the other part is like, I play the game as well, right? Like all the time. I have over 2K hours, and it is pretty frustrating at times when, I'm running a 4070 Ti and I'm getting like constant hitches here and there, or I'm seeing visual issues. And yeah, it's definitely one of those things where it's like, by playing the game, I'm even more kind of motivated to improve it, just not for myself, but for everybody. And so I think that's one of those things where like each engine upgrade kind of has allowed us and unlocked us the ability to look into certain things, use new tools, but with it comes the actual time investment you need to put in first to actually use those, right? And so, that can be a little bit frustrating. Definitely understand that side. But it is something we're working on, and hopefully people start to see the results, especially with some of the immediate stuff that we've listed before for 10.4.
I want to echo that. We're just trying to be more transparent as well why we're doing things, even if it doesn't have immediate impact. I want to say our data supports that you are not wrong when you are complaining about issues, and maybe most people don't see them. Like we do see that there's a lot of variance in the results that you get. Like even we have a bunch of those, like we have 10 of those GPUs, and we do get different results if we set up 10 systems with them. It's very true that you can have individually different experiences to people on similar hardware. Right? You're not wrong in having those experiences, not just you. Right? There's going to be other people who have similar experiences to you, and we do try to address these issues as quickly as we can. It gets hard when we can't repro them. We're trying to test on as many systems as we can, and we're trying a more general approach of understanding what are bottlenecks and removing them, so that hopefully everyone can have an improved experience, improved performance. without just focusing on the sort of limited number of systems that we can have in the office. But we're not living in a different world, right? We're playing on the same systems as you, and we're using entry-level GPUs. We're not isolated from any performance issues. Like we see it just as much as you.
Well, I appreciate you guys doing this. It is always very helpful to have this conversation. I learn something every time we have this conversation. I realize that there's probably a bazillion questions we could cover, you know, over the next 12 hours if we had that much time. But I think it is very informative, and to the point of transparency, it's very helpful because not only am I learning, but I'm gathering more and more knowledge about the process that you guys work through, and then kind of how it affects us downstream. Especially when it comes to like maps and stuff like that, something that's very tangible for us to see, like, you know, some progress on, and then how that goes from, okay, we got to take this legacy map, update assets, and then eventually it gets to us. So it's very informative, very helpful. So I really do appreciate you guys and the time you've taken with hanging out with me today and answering some questions. So obviously this is a pretty dense interview. When it comes to this sort of thing, I try to leave as much in as I can. With this, I did have to do some editing. I think the interview went on for almost an hour and 40 minutes. I trim out stuff like redundancy or just prolonged answers, maybe an extra example that comes in with the answer. And in looking back, I only cut one question and answer, and it was tied to visual ghosting because I just don't think I formulated the question very well. Now I realize there's probably a ton of questions you guys wish I would have asked, especially some of you that are more advanced in understanding Unreal Engine, performance optimization, and environments. But I'm not as advanced, and I do want this video to be something that can be communicated to people that may be interested in learning more, along with trying to provide whatever information I can around where the game is and where it's headed. Now, an aspect of the conversation that I thought was very valuable was talking a little bit about the developer pipeline and moving 5.7 along so that more updates can come out based on the new tech that is allowed in the Unreal Engine. Because during this conversation, you notice that there are several things we're talking about that aren't quite ready for release, but it is dependent on getting 5.7 out. The next thing is that there's an optimization patch utilizing some of this tech and other stuff that they've done to try to improve performance, especially on the memory side, that will release after 10.4. Now, the effort going into performance and optimization seems to be a pretty significant one because they are having to go through all of these maps and improve just about everything from an environment standpoint to try to get it to perform better and allow for more VRAM usage in other areas. I don't know if I was necessarily surprised about the focus in moving the legacy assets forward as much as it just seems like a much larger undertaking than maybe I grasped earlier on. So while maps and environments are getting some baseline treatment to get legacy assets closer to, I guess, the performance expectations of Offworld, it does seem like the Eastern European Biome rework is going to be really the measuring stick to see how performance with everything updated for Unreal 5 is going to go. My hope is not only that it sheds some light on what Offworld's working on and some of the details around it that aren't covered in other pieces of media, but it also serves as sort of educational for folks that are learning and trying to understand what's going on with the game that they're passionate about. I hope this is something we can continue to do and explore other areas of Offworld and the development process. So if you'd like to carry on the conversation, you can do so in the comments, or you can join my Discord, which is linked in the description. You can obviously hit the subscribe button, which I would appreciate. If you want to support the channel, there's memberships available as well. But with all that said, thank you for watching the video, and I'll catch you next time.